Hello. So let's talk about geometric series today. Okay, so consider a real number a and another real number q. Okay, any two real numbers. We can make a sequence of numbers. We start with a, then a times q, aq squared, aq to the power 3, aq to the power 4, and so as many terms as we want. Okay, all of these will be real numbers because a and q are real numbers. Now, what is going on? Each time we are one term up, we are multiplying by q. So a is the first term, and q is the multiplication factor that allows us to go from one term to the next. Okay? So we can use some proper notation. We say x1 is the first term of the sequence a, x2 is the second term, x3 is the third term, x4 is the fourth term, xn plus 1 is the n plus 1 term. Okay? Notice that n plus 1 term of the sequence is the first term, x1 to the power times q to the power n. Okay? So in general, we have this formula here that the term n plus p term of the geometric sequence is the nth term multiplied by q p times. Okay, p times. You have to move up in the sequence p positions, you multiply by q p times to get there. Okay, what about, so this is an important formula. What about the sum of terms of a geometric sequence? So let me call Sn the sum x1 plus x2 plus x3 up to xn. So this guy here is the xn. This is the x2, etc. I'm adding x1, x2, x3, x4, x5 up to some xn. Okay, and I'm using this formula here. So to calculate this sum, I multiply every term by q, both sides. Okay, q times Sn, x1 becomes q x1, qx1 becomes q squared x1, etc. Up to this term multiplied by q becomes q to the power n x1. Alright? Now I subtract this first equation minus the second equation, Sn minus qSn, and this term here, qx1, cancels with this. And I cancel it like this, like this, like this, all the way like that. And I'm left with x1 minus this guy here, qn x1. Okay? And now my sum, this Sn I put in evidence, I have a factor 1 minus q times Sn. Here I have x1 in evidence, 1 minus qn. So that's my formula. If q is different from 1, because if q is equal to 1, I cannot divide both sides by 1 minus q, because I cannot divide by 0. So if q is 1, this sequence here is just a constant sequence. That is a, as many times as you want. So if you add n times a, n times x1, you find n times x1. So if q equals 1, this is easy. Otherwise, we have this beautiful formula that is very important in finance, mathematical finance. Example of geometric sequence or geometric series is 100, 110, 121, 133.1. What's going on? Each time I'm increasing the quantity by 10%. I start with my first term is 100, and then I increase, I multiply by 1.1, so I increase by 10% the quantity. Okay? So suppose b and c are two positive numbers, okay? And I do this calculation. I know that the square root of b minus square root of c, this is a number. It could be positive or negative, I don't know. But if I square, I have something greater or equal to 0. Okay? More than that, I have the equal, if and only if b is equal to c. Okay, if b is equal to c, this is 0, otherwise this is going to be strictly positive. Okay? Now, I developed this. The square of the first minus 2 times the first times the second plus the square of the second term. The square of square root of b is positive, remember, that's b. The square of square root of c is c, minus 2 times the product of the roots, the square root of b, the square root of c is just 2 times the square root of bc. I push this term to the other side, I divide by 2, and I find this, b plus c over 2 is greater or equal than square root of bc. And again, remember, equality holds if and only if b is equal to c. Now this guy here is just the average between b and c, the arithmetic mean. Okay? And this is what we call geometric mean. It's a quantity called geometric mean of two positive numbers. And it turns out that the arithmetic mean is always greater than geometric mean. They are equal if the two numbers b and c are the same, because the average of two numbers which are the same is the number itself. Whether it's a arithmetic average or a geometric mean, it doesn't matter. Okay? So for instance, here, this is the first term of the sequence, this is the third term of the sequence. What's the geometric mean of 100 and 121? You multiply this by this, and you take the square root, and you're gonna find the guy in the middle. Notice 110 is not the arithmetic mean, right? If I were to add these two numbers, I would have 221, and half of 221 is 110.5, not 110. The arithmetic mean would be bigger. This guy here in the middle of the geometric series is the geometric mean. And that's what I'm calculating here. The geometric mean of the first term and the third term of a geometric series is the second term. The geometric mean of the first and the fifth term, well, who's the fifth term? That's gonna be the square root of the first term. The fifth term is x1 q to the power 4. And when I have x1 and x1 square, the square root will have an x1 and a q square. So that will be the third term. That will be the third term. x1 q squared. Okay? In general, if I have the geometric mean of the nth term of a geometric sequence and the nth plus k term, I'll have the n plus k. n plus 2k here, okay? You got x n plus k. Try to prove this. It's gonna be not too hard, hopefully. Alright, this is the geometric series, very useful in financial mathematics, finance. See you guys next time. Bye bye.